Okay.
13-year-old Sydney Kendall trying out her new 3D robotic arm.
Well, I think this one's cool because it can move the whole hand, and it's pink, so that's cool.
She lost much of her right arm in a boating accident 7 years ago.
It was very traumatic for our whole family, but she has taken it in stride, and she has come a long way.
Sydney has two standard prostheses, a cosmetic one that she wears for balance when she skis, and one that allows a pinching movement she wears while biking. But nothing like this one. She controls it with shoulder movements. The fingers and thumb can move together or independently, allowing her to grasp and pick up light objects.
I was blown away. You know, she can pinch stuff now with her prosthetic, but, you know, picking stuff up like that, no way. So it was pretty neat.
You did. Okay. You got the movements.
The idea was born of 3 engineering students at Washington University.
It was our class project for our senior design class.
The first step of it is to design the parts that we're going to end up making on a computer program, so you can rotate it and see the hand from different angles.
They aced the assignment, then decided to turn design into reality.
Our mentor for the class project were Dr. Goldfarb and Dr. Wall, both hand surgeons at WashU.
Well, I'm sure I'll be using this.
Sydney's one of their patients, and they hooked us up with her.
A 3D printer would do the job. The students created a file with settings and directions and fed it to the printer. It starts printing each part from spools of plastic that is heated to melting.
This part, when you print it out, will take around 20 minutes.
Larger parts can take hours. Total time about 13 to 15 hours of printing. Then they add all the internal gadgets that make it work.
And what we did was we came up with a way of basically coordinating shoulder movements to opening and closing of the hand.
A sensor worn on the shoulder detects motion, sends a signal down the cable to a microcontroller chip in the arm, which activates a motor for each finger, all powered by a 9-volt battery.
If I move my shoulder up like that, it opens, and then when I move it down, it closes. And then when I move my shoulder forward twice, the thumb opens, and when I move it back twice, it closes.
Another big plus, it costs about $200 to make, compared to thousands for a normal prosthesis.
That's one of the reasons that the high-tech moving prostheses are not really available for children very often, because of the cost.
And you can bet Sydney will get the most out of it.
She's very excited to take it to school and show her friends.
I think they're going to think it's really cool because they've just never seen anything like this, especially since it's made from a 3D printer.
Thank you.
Made by college students who made a friend for life.
Could do a high five.